Hello everyone. Before I get started today, first of all, this is where we stopped. Problem number 3 on chapter 9. And I should let you know that the second video of chapter 9 is only like about 5 minutes and some seconds. The reason for that, my camera is limited to 26 minutes and some seconds, I think 27 or 28 seconds total time for each setting, for each video that I shoot. So last time I noticed that I did go over 30 minutes. So it chops the clip by 26 minutes and 27 seconds or 28 seconds. And then I noticed that the rest of it was transferred to a different file, which was like about 5 minutes and several seconds. So from this point on, I have to make sure that when it gets up to 26 minutes, I have to stop and do another video. Anyways, this is video number 3 of chapter 9. We stopped at problem number 3, and we did problem number 1 and problem number 3. Now we continue with chapter 9. If you guys have the PowerPoint, the old PowerPoint ready, go to slide number 12. They're talking about type 1 and type 2 errors. Let me tell you what it is that they're talking about. When we are going to do the hypothesis testing, we do make mistakes, which in hypothesis testing, this making mistake is known as committing errors. And there are 2 types of errors that we commit when we are going to do the hypothesis testing. These 2 errors are known as type 1 and type 2 errors. Type 1 error is when we reject the H0, when we reject, well, it's on the slide, but type 1 error. So type 1 error, reject H0 when it is true. So when H0 is true, example, when Coca-Cola company claims that they are giving you at least 12 ounces of drink, if that is true, if that's when we go in and do the testing, we measure everything, and the average amount of drink in each can measures at least 12 ounces. If we go in and reject the H0 by any mean, by any reason, then we have committed type 1 error. And they say that it is not uncommon that we do make this kind of mistake. We call it type 1 error. Type 2 error is when we accept for type 2 error, accept H0 when it is false. All right? This is called type 2 error. In order to do the hypothesis testing for making sure that we do not fall into committing any one of these two errors, we are using two different methods. So again, in order to make sure that we don't make this kind of mistakes when we do hypothesis testing, there are two methods that we use. One is called p-value, the other one is called critical value approach. P-value approach, critical value approach. Now, what is the p-value approach? P-value approach is based on the concept or theory of the alpha. Those of you who remember, going back to chapter 8, if you guys remember, we said when we were going to develop that range to create a margin of error, x bar plus or minus z sub alpha over 2 times sigma over the square root of n for sigma unknown case, and t sub alpha over 2 times s over square root of n for sigma, x plus or minus z sub alpha over 2 times sigma over square root of n for sigma known case, and then for sigma unknown case, x plus or minus t sub alpha over 2 times lowercase s over square root of n. So when we were using those two formulas in order to develop the range, we knew that the area under the graph, which is 100%, is not going to be the probability to provide support for our x bar to include the mu. If the total area under the graph provided this enough support, all the area under the graph was the support for x bar to include the mu, then x bar would have been equal to the mu. And if you remember, we said that this only happens in perfect world. All right? So we know that the area under the graph is not going to be all 100% providing support for x bar to include the mu. Then we said the whole thing is equal to 1. There is some area that doesn't provide support for x bar to include the mu, that we call it alpha. All right? Alpha is the area that does not provide support for our x bar to include the mu. This is what we learned in chapter 8. Now in chapter 9, we're still going to go ahead and use that alpha. We say that, let's say that this is the value of the alpha. Okay? Again, if you remember, if we're dealing with 90% confidence level, then alpha is equal to what? 0.1. If we do 95%, then alpha is equal to 0.05. If we're doing 99%, then alpha is equal to 0.01. If we're doing 80%, then alpha is equal to 0.2, so on and on, right? Now, when we are going to do the hypothesis testing, I just received this emergency alert, public safety alert. LA County's COVID-19 health officer order is in effect. I'm sure that you guys have received it too. But anyways, so when we are going to do the hypothesis testing, because we know that we are making those errors, like type 1 and type 2 error, then we do use a test which is called p-value approach or significant test. Significant test is basically measuring, or p-value approach is calculating the probability by using z-value. Z is called test statistic. Computing the probability using test statistic, that means using z. If you guys remember x minus mu divided by sigma, calculating the probability using z to see if that probability provides enough support for our sample to accept H0. If it doesn't provide enough support for our sample to accept H0, then we have to go ahead and reject H0. How is this going to happen, this p-value approach? We go ahead and measure the probability for p-value. If that probability falls anywhere within this area, this is where we accept the H0. If that probability, our p-value, falls anywhere on this line or to the right-hand side for upper tail, in the area of that, if it goes over to this side, it gets into the alpha area. And alpha is the area that the support is not provided for our sample to support the population parameter. So that is called p-value approach. I'm going to talk to you guys about that a little more in depth and detail. And then there is another method called critical value approach. But for now, let's go back to type 1 and type 2 error. Type 1 is when we reject the H0, but it is true. And type 2 error is when we accept H0 or null hypothesis, but it is false. To give you an example, if in a court of law we have this plaintiff and defendant, and the null hypothesis by district attorney is always knowing that the defendant is guilty, right? That is the null hypothesis. If they commit type 1 error, what would be the outcome? What would be the decision of the court for this individual? Now let's go according to the definition. The null hypothesis says that the defendant is guilty. If we go ahead and reject this null hypothesis and it is true, but we go and reject it, then we come to the conclusion to believe that the defendant is not guilty. So we set the defendant free while we should have not. This is an example of type 1 error. Let's use the same example for type 2 error. Accept the H0 when it is false. So the null hypothesis says that the defendant is guilty. In type 2 error example, if we go and accept this while the defendant is not guilty, what would happen? What's the end result? We are punishing an innocent individual. This is another example. All right? So now we're going to go ahead and do a problem for, I think, type 1, type 2 error. Problem number 7. This is a good example talking about the type 1 and type 2 error. Problem number 7 for 11th edition users, page 356. For 12th edition users, page 390. For 13th edition users, page 395. Problem number 7. So I want you guys to go ahead and read the problem, please. Chapter 9, problem number 7. Part A. Develop the appropriate null and alternative hypotheses. So H0 states that the mu is less than or equal to 8,000. HA states that the mu is greater than 8,000. For those of you who thought that this should be greater than or equal not equal, I'm going to help you understand or why we came up with this hypothesis. It says the salesperson, Steve Contois, the firm's vice president, proposes a compensation plan with new selling incentive. Incentive. Why do you give someone incentive? In order to reach something that you would like them to reach. That means they are not at that state at the moment. Okay, let's just lead a little further. Steve hopes that the result of a trial selling period will enable him to conclude that a compensation plan increases the average sales per salesperson. So we should assume that at the moment it's either 8,000 or less. Because if it was 8,000 or more, or even exactly equal to 8,000, why does he have to worry about increasing it to 8,000 or more? So the assumption is that it is 8,000 or less. Therefore, he's trying to give him incentive to see if it goes over 8,000. That's the explanation for part A. For part B, what is type 1 error in this situation, and what are the consequences of making this error. Type 1 error is giving incentive while they should have not. Now let's go ahead and see what would be the outcome, the consequence of the type 1 error. Type 1 error says reject H0 when it is true. If Steve commits type 1 error, they will go ahead and reject this while it is true. This is true. But he will go ahead and reject it. What happens if he rejects this? He will accept this. If he accepts this, it's going to give him the incentive while they did not deserve it, because this is true. And then part C is going to be different. They don't give them the incentive. Do not give them incentive while they should have. For type 2 error, Steve comes to the conclusion to accept this, but this is false. If they accept this by mistake, then they accept this by mistake, they believe that the sales is not greater than 8,000. Therefore, they don't give them the incentive, but they should have, because this is true. Because this is false, but Steve accepted it. So this is a good example for type 1 and type 2 error. I'm getting to 22 minutes. Let me see how much more I can cover for you guys. I'm trying to take advantage of all the minutes in here. Slide number 15, they're talking about the p-value. Now again, p-value is the probability computed by test statistic to show if there is a support or lack of support for our sample to either accept H0 or reject the H0. Again, going back to the concept of p-value, you're going to have the case that requires us to first go ahead and calculate the z. Once we find the z, we go to the table, we find the area based on which case we have. Do you guys remember I said that this is mu H0 mu greater than or equal, this is one tail, lower tail, H0 mu less than or equal, mu sub 0, mu sub 0. I'm not including the alternative hypotheses, okay? Mu sub 0. And this is one tail, upper tail, right here. And then when we have mu equal sub 0, mu not equal to mu sub 0, H0, HA, then this is two-tail hypothesis testing. That means based on the z for this one, we go and find the area, the probability, and then we measure that, see, this is where the alpha is. This is where the alpha is. This is half of the alpha. This is half of the alpha. If that area that we measured is equal, if p-value, this is the rule for it, if this is less than or equal to alpha, then we reject H0. So if the p-value is equal or less than, that means if it is going to be located in the area of the alpha is the rejection area. The alpha is the area that our sample does not provide support to include the mu, does not provide support to accept the H0. All right? So this is it, exactly 26 and 2 seconds, 26 minutes to now 4 seconds. Thank you, I'll see you guys later.